Hello dear students, welcome you all. In this lecture, I am going to start a new topic in physics, that is digital communication, right? Digital communication, right? So this word digital communication, I think it is not a new word for anyone. Nowadays we are listening this word many a times when we talk about the different communication systems. We talk about the different telecast channels. All of them are making the use of digital signal technology, right? So first of all, before going into all that topic, we have to understand the basic difference. What is the difference between a digital signal and a analog signal, right? So analog, and here it is a digital, right? Digital communication means we are making the use of digital signals for a signal processing and communication. Analog means we are making the use of analog signals, right? Now analog signals, we know what are analog signals. These actually signals are if I draw the waveform of this analog signal, it will be here analog, and here it is for digital, right? So now I'm talking about the first analog. Analog means any signal that is varying continuously with the time. I can say this signal, if I look at the voltage level of the signal with time, then we can say it is varying continuously with the time, right? So we call all these type of signals as analog signals. It can be of the form of a sinusoidal wave, non-sinusoidal wave, but the main thing is that they are continuous in nature. They are varying continuously with time, right? But if we look at the digital signals, then these signals are not continuous, but rather they are discrete, right? In these signals, we will have only a few value of the signal allowed. I can say if I this 1, then 0, right? Then again 1, right? Right, like that. So you can see here that the signal is now discrete. It is not continuous, right? This type of signal, right? This is the rough representation of a digital signal. Now you can see in this signal there are two values allowed, either high or a low. Clear? So we can say 1 or a 0 in terms of digital electronics. Now this type of signal, this is not a continuous signal. Remember, this is totally different from analog signal. So this type of signals are called digital signals in electronics. Digital signals have only two possible values for the voltage or current during their variation, whereas in case of analog signal, all values are allowed in the given range, whether it is from 0 to some particular value, or it is from negative value to positive value. So all the values in between that range are allowed in analog signals. What in case of digital signal, we will have only two levels, either you can say 0 or 1, right? Here 0 ones represents the binary digits, but in case of electronics, we can say 0 stands for 0 volt, 1 stands for plus 12 volt, plus 6 volt, we can say. So this is the difference between analog signal and digital signal. Now the thing is that in nature, almost all the signals that we see around us, they are analog in nature, right? They are not digital. Clear? Nature is somehow continuous, right? all the signals, all the things that we see around us, they can be represented in terms of analog signals. Now, if I want to convert that analog signal into corresponding digital signal, then I have to follow a certain process, right? I have to use a electronic device for that. So this process of converting analog information into corresponding digital information is called A to D conversion, right? And then after that, digital format of that information will be used for a communication purpose. But here, students, you can ask a question: why we are preferring digital format of the information? Why we are not relying on the analog format? So you know very well that in the previous technologies, right, we were totally dependent on analog signals, the use of analog signals for communication purpose. But it has several drawbacks, several disadvantages. So with the passage of time, we have developed digital systems. We have seen that these digital systems, digital signal processing systems, they are more efficient, they are less prone to the noise, they have high bandwidth, and all these things are there. So you see that nowadays when we use mobile phones, or you can have a television, you can see there. So all of them are using digital format of the information for transmission, and we are getting very clear quality of the whether it is sound or whether it is a picture, right? So this is the difference, that why we are going from analog to signal, right? So this is the difference between analog and digital. Now the process that is followed for the conversion of analog information to the digital format, that is displayed here. You can see here what process we follow. So you can see here, right? This is basically a 3-step process. You can see here. First of all, we will do the sampling. Clear? You can see here what we do. We do the sampling. Clear? We have an analog signal here. This is analog signal, right? You can see here, continuously time varying signal. Analog signal is continuous in time and amplitude, right? Now when we do the sampling, now this is the sample, corresponding sample of this analog signal. Now here, instead of having continuous variation, we have discrete variation. We have selected only certain amplitude, like this one, this one, this one, this one, this one of the input analog signal, right? So we have captured the information from this analog signal. Then after, we will convert this into quantized values. This process is called quantization. We will convert these values into some predefined values, right? Now have discrete values in both time and amplitude. Now then after what we will do, we will convert these different values here into some predefined levels of the voltage, right? Then after, what we will do, we will encode them. That is done by the encoder, right? Encoding assigns binary numbers to the amplitude values. These amplitude values, we will discuss all these 3 processes one by one in this course, right? We will start with the sampling, then quantization, and then encoding. Finally, we will have this. You can see here. Now it is a digital information, that is in the form of binary numbers, 0 and 1s. Right? Then this information, this signal is transmitted by the antenna, right? And at the other end, it is received by the antenna, and then after processing, we recover the original information, right? So this is the 3-step process shown here. So you will start with the first step, that is taking the sample. So for taking sample of this information, we must have some rule how we can take the information, because here one thing is very important. Taking the sample of the information is one aspect. What we will do when we will recover this information back, right, in the processor, right? What will be there? So while taking the samples, right, from the input signal, we must keep in mind that this these samples should be capable of regenerating this input analog signal here, right? So there is a rule that is known as sampling theorem, right, that gives the condition for sampling. So first of all we will discuss the sampling theorem, right? So well, in the next lecture we will start with the sampling theorem, and then after we will discuss sampling theorem for the two different cases, that is for low pass signals and for band pass signals, right? So thank you very much.